We have 216 participants right now. I invite questions and the forum is open. If you have any queries, if you want to share any of your experience, or if you want to know anything more, please raise your hands, please open up and you can ask your queries. We are taking a quick 20 seconds break. Okay, so now I am sure all of you must have very clearly understood what is the value chain of analytics, how when we mature, when we use more and more and more mature statistics, more and more mature AI and ML, what is the value that we can generate? But then the most important question would be, how do we generate this predictive models? How do we generate forecasting models? How do we generate this AI and ML model? And I want every one of you right now to focus on the slides. Can you please all pay attention to the slides? The slide talks about how to develop a predictive model. And this must be in mind of everyone. Like we heard a lot about AI, we heard a lot about ML, we heard a lot about predictive models. How do we develop these models? So this is a very as you develop a predictive model for your for forecasting your VCs. These steps are simple and they follow simple steps. So to start with, the first is to, are you running a 100-meter race? Are you running a 200-meter race? Are you running a relay race? Or you are running a slow cycling or slow walking race? Because until and unless what are you running for or what are you working for, you will not understand what is to be done. So the first step in developing a predictive model is to define the problem statement. And remember, in this course today, we are going to learn several critical things about defining a problem statement. Because if you define a problem statement that is vague, that is not accurate, that is not right, and that is not what your client wants, you will never be able to deliver those things. So remember that defining a problem statement is one of the most critical part of developing a predictive model. So defining a problem statement, let me take you to the next part, and that is known as preparing the data. Now, I'm sure every one of us understand that when we talk about AI, when we talk about ML, the most crucial part is data. If you have no data, then no AI and no ML can be developed. It's all about data. But then if somebody comes and tell you, okay, I have 10 GB of data, I have 100 GB of data, I have 200 GB of data, develop an AI and ML model on top of it, is it right? Is it possible to develop data on whatever is available to you? No. Because remember that AI and ML, those are simple mathematical algorithms. It's like the data that you feed to the algorithms will learn from that data, and based on those algorithms only, you will start getting output. So until and unless the data that you feed to the algorithm is right, is appropriate, and it is in the most correct way, you are not going to arrive at the most appropriate results. Now think it from a COVID point of view. Okay, you are developing a model it's going to predict how vast or how far is COVID going to spread in some regions, say in Mumbai. So now the data that you have is not correct. Okay, you're not using a correct data, whatever is available to you, whatever you got from internet, whatever you got from some other sources, you simply put that data into a machine learning model and then you start developing a model. So what do you think? That the output of the model will be reliable? Can you ask your government, your local authorities, your municipal authorities to take decisions on the machine learning model that you have developed? No, you cannot ask them because the model that you will develop, the output, the results of your exercise are not going to be reliable. And that is why, if you read on the slide, in the overall um, in the overall process of developing a predictive model, 70% of the time is spent on of a data science project or a machine learning project in preparing data. And that is most important because until unless you can come up with a reliable output on which you want your teams or your organizations to take decisions, no value is going to come out of machine learning model. From data preparation, the next step is to understand which model to choose. Now, going forward, we are going to see that when we talk about machine learning and AI, it's a huge cloud. It means there are hundreds of models that are available. There are hundreds of varieties of statistical analysis as well as machine learning analysis that can be done. But then, until and unless you select the right, right machine learning model, you will not be able to generate the best output. Now assume that you are a football player, okay? And when you are playing football, it is most important for you to understand what is the turf or what is the ground on which you are going to play your football. Are you going to play on a muddy ground? Then you need to wear different kind of shoes that has spikes in it. Are you going to play on a ground that is very smooth or on a concrete ground? Then you don't need spikes on it. You need a shoe that has rubber sole that can give you friction, that can give you strength while you run and walk and play football on the ground. So it is important. Now just imagine that you are wearing spike shoe and then you are playing on a concrete turf. What will happen to you? You will not be able to run. You will not be able to make scores. You might fall. You might break your leg. Or you might get other injuries. And that's why when we talk about shoes and select shoes while we are running to play football. Similarly, while we are developing predictive model, it is most important that we select the most appropriate or we select or we choose the right model. We are going to learn how to choose the right model in these hours of workshop. From there, let's go ahead and talk about once we know the model, does that only help? Like knowing the model, having the data, we have to train the model. Right? Until and unless we train the model, there is no intelligence that the algorithm has. You have your lab, you have Python installed on it, you have all the libraries, you have everything there. But until and unless you train the algorithms, you train the machine learning model, they will have no intelligence at all. Now just imagine you have a mobile phone, okay? It has camera, it has all the features that is needed, but the mobile phone does not have Android operating system or it does not have iOS operating system. How is that mobile helpful to you? Or how are you going to make use of the camera and taking photographs? Is that possible? No, it's not possible. So until and unless intelligence is built on the hardware, there is no way you're going to make use of that intelligence or that hardware. And that is what we know as training the model. From training the model, the next step is to evaluate the model, to fine tune the model further so that you get the most reliable outcome. And from fine tuning the model, the final step is to deploy these models online to make predictions in real time. And I think this is the most crucial step where we just not make machine learning models. We just not talk about developing models and using data, but then we have to deploy this model online so that they can help you in real time. Your teams, your CEOs, your government authorities can benefit from the models that you deploy in real time. And this is the entire part or the entire process of developing machine learning and AI model. It starts from defining the problem statement, then preparing the data, choosing the right model, training the model, evaluating the model, parameter fine tuning, and making predictions. Now, we started the topic with statistics. So, we are going to learn about statistics first before we go into machine learning. And I want you to understand why are we studying statistics? And that's because if you look on your screen, statistics plays a key role if you talk about preparing the data. It plays a key role in in evaluating the performance of the model. It plays a key role in fine tuning your model and generating more and more reliable data. And it helps you deploy those models in real time and make real time predictions. And that is why the topic that we are going to discuss right now, predictive models, statistics, AI, ML plays a very key role. From here, let us now go forward and talk about variables. Now, why are we talking about variables? And that's because we talk about defining a problem statement. Now, to define a problem statement, it is so important that understand the concept of variable, what are variables, what are the different types of variable, and why are variables necessary. Okay, so let's start with variables. So when working with a statistical data, you need to get acquainted with different types of data. The different data types are used in separate cases and require different statistical and visualization techniques. And that's why it is very important that you understand what are variables, what are different types of variables, because until and unless you understand different types of variables, you will not be able to select the right type of machine learning model. Therefore, you need to understand the different types and their analysis. This knowledge is what is used during analysis of any use case that is available to you. Let's take an example. Okay, on the screen, what you can see right now is one sample case where you want to understand the amount of money you spend. We know that it is dependent upon the amount of money you earn. Okay, in most of the cases, the amount of money you spend is dependent upon the amount of money you earn. Now, it's a very general understanding, it is common sense. But to develop a model or to develop a mathematical understanding on it, you need to understand what are different variables. And if you want to predict, then we need to develop a mathematical formula for it. To develop a mathematical formula or relationship between the amount of money you spend, the amount of money you earn, the most important concept is variable. Okay, so let's understand a little more about variable, and let us take a different example. Okay, now you want to predict the failure of an engine in a truck. Okay, so for example, there is a truck that is riding from Delhi to Pune, and this truck, while it is driving from Pune to Delhi, it is carrying 20 tons of load. Now, when it is carrying this 20 tons of load, and it is critical. For example, let's understand that it is carrying vaccine from Delhi to Pune, and now you want to make sure that this truck reaches Pune on time. Okay, so it is carrying around 20 tons of load. Now, to do this, what you need to know is what are the environmental conditions, what are the road conditions, what is the health of the truck, what is the capacity of the truck, what are the different maintenance records, or what is the different maintenance that was performed in the truck, etc. So all these data have different characteristics. For example, environmental condition, like if there is raining or not, what is the temperature outside, what is the humidity outside, what is the visibility outside. So this has a different characteristic as compared to the health of the vehicle. Okay, so now let's take another example of maintenance records and the speed of the vehicle. If your truck is overloaded or it is within load and the fuel that you consume, so these are the different examples of different types of variable, and each variable in this case is important, because until and unless you know how much load you are carrying, or if you are overloaded or if you are underload, if you have sufficient fuel or not, what is the fuel consumption rate, how is the condition of the road or not, you will not be able to predict if your truck will reach on time on the destinations. And these are called variables. So to define a problem statement, you first need to understand what are variables, and based on this you will be able to define, like, this is my problem statement, and for this what I need is the data. So variable can occur in any form such as trait, it can be a factor or a statement that will constantly be changing. Remember this, this is very critical, that it must be changing according to the changes in the applied environment. Such variables in statistics are broadly divided in two categories. Okay. Now we are going a little deeper into understanding of this. They are broadly divided into two categories. One is known as numeric, and the other one is known as categoric variable. So these are other ways also of looking at the variables, such as you may also find variables which are known as dependent variable, and other form are known as independent variable. But that is more from an analytics and model development perspective. So right now we will consider numeric and categorical variable but you may also remember that variables are also known as dependent variable and independent variable. Okay, for example, let's go back to the same example that will your truck reach on time or not. So reaching on time or reaching not on time is known as a dependent variable, and the other environmental factors that we consider that we discuss right now are known as independent variable. Okay, because the temperature outside in the environment is not dependent upon anything. It is not dependent on how your truck moves, but it is an independent variable, and the temperature is dependent upon, or the truck performance is dependent upon the ambient temperature, and that's why we call it as dependent variable and independent variable. Okay, so I've taken here some more examples of different types of variables that we see in our daily lives. Okay, so when we talk about variables, let's take example of a car. So from a car perspective, if your car is on or if your car is stopped. So if your car is started or if your car is stopped, it could be one type of variable. The speed of the car could be another type of variable. Let's go into energy transmission. See how much energy is transmitted on the lines that we see on roads. So that can be measured in terms of megawatt, kilowatt. So measuring energy transmission in megawatt or kilowatt becomes your a type of variable. Then the web browsing that we do on our mobile phones, that we do on our laptops, which website, for what many hours, what were the keywords that we search for. So that becomes a different type of variable. Then the amount of energy that we consume in our homes, in our hospitals, in our offices, in our schools, in our colleges, the energy consumption becomes a different type of variable. Okay, it talks about number of units that we consumed in a month, in 15 days, in a day, or in a week. From there, let's go to manufacturing. Now, if you are manufacturing a medicine or you're manufacturing a vaccine, now what is the quality of the vaccine that you have manufactured? Is it good? Is it bad? Is it on spec or is it off spec? So, specification or quality of the vaccine or the quality of the medicine that you create is also a type of variable. Now, let's take an example of a windmill. Okay, so you want to predict what is the wind energy that you want to generate, that can be generated. So, in order to understand what is the wind energy that can be generated, the most necessary is for you to know is what is wind speed. Until and unless you know the wind speed, you cannot predict what is the wind energy that will be generated, and that is why wind speed becomes one kind of a variable. From wind speed, let's go on to talk about solar power generation. Solar intensity, or what is the solar intensity is the, because solar intensity is dependent upon how cloudy is your environment, is it day or is it night. So the amount of solar energy that will be generated depends upon if it is day or it is night, what is the solar intensity, how is your environment, is it cloudy or it is not cloudy. So these becomes different types of variable. Then let's come back to looking at COVID as an example. Now, most of you must be using Arogya Setu app, or you must be using different apps when you go to malls, when you go to your colleges. These are some of the three questions that are generally asked for. One question is, have you had international travel in last 15 days of time? Either you will say yes or you will say no. This becomes one type of variable. The second is to look at your body temperature. So is your body temperature less than 30, less than 36, or it is more than 36, 37, or whatever is the limit. So these type of numerical data becomes another type of variable. And the social distancing in meters, in feet, that is maintained between two different persons when we go to mall, when we go to railway stations, when we go to airports, become a different type of variables. Okay, so right now we have taken these many examples of different types of variables, and I want all of you to imagine and focus scenarios around you where you can identify different type of variable. Okay, so every day in real life you need to understand, you need to focus on scenarios around you wherein you can identify, okay, right now I'm sitting in an air conditioned cabin or air conditioned room. The temperature of the air condition is set to 25 degrees. So that is one type of variable. And the other type of variable is if the if the engine is, if the machine, if your air conditioner is running or if your air conditioner is not running, that becomes a different type of variable, right? So every one of you, I request when you move along for next couple of months until and unless you grasp this, what are the different types of variable, what are variables. I want all of you, I request all of you to look around you and then focus on what are different types of variables. Okay, from here let's go a step forward where we define these variables. Okay, now when
Sunny,
we talk about,
Sunny,
yes, yes, Arun.
Sunny, there was a question. Can you define variable in one statement?
Can we define a variable in one statement? Okay,
Ah,
okay, now can you please read the slides? So variables are called variables because they vary. That is, they can have a variety of values. So variables is something which varies over a period of time. It does not remain constant. That is first. Second, it helps you to get characteristics of the data or the problem statement that you are working on, and that is how we define a variable. First, it should vary, and second, variable is something or it is a trait or a factor or it can be in any form that helps you to understand more about the data, and that is what we call as variable. From here, let's go a little deeper into understand what are different types of variable. Okay, so we started talking about where we said that variable is two forms. One is what is known as numeric variable, and second is what is known as categorical variable. Okay, so numeric variable and categorical variable. Remember this. So numeric variable is something where we have numbers. So numerical data is a data type that is expressed mainly in numbers rather than natural language description. For example, what is the temperature of the room right now? The temperature could be 25, 26, 22, 21. To define this in terms of numbers, so it becomes a numerical variable. Now, is your AC running or it is not running? So running and not running becomes a different type of variable that we will go forward in study. Okay, so numerical data type or numerical variable has a data types that can be expressed in numbers rather than natural language description. Running or not running is what is known as natural language description. Okay, sometimes these data are also known as quantitative because you can quantify. What's my weight? I can quantify. What is the amount of money you have? It can be quantified. What is the amount of chocolates you have? Can be quantified. So numerical data is always collected in number form. Numerical data differentiate itself from other number form data types with its ability to carry out arithmetic operations. This is very important. See, we can only perform arithmetic operation on numerical data, on or off. We cannot sum on plus off. We can sum 1 plus 2 equal to 3, but there is nothing what is known as on plus off. So, numerical data has got one of the most important characteristics that arithmetic operation can be performed on numerical data. So remember, in your problem statement going forward, wherever you want to use arithmetic operation, define your variables as numerical data. Okay, let's take another example. So numerical data of number of kilometers a vehicle is driven. Say in the month of January, the truck was driven for 1000 kilometers. In the month of February, the truck was driven for 1200 kilometers. So cumulatively, the vehicle was driven for 2200 kilometers in 2 months. This characteristics is one of the major ways of identifying numerical data. Now, going, going forward into numerical data also has two forms, mainly discrete form and second mainly continuous data. Okay, so numerical data we understood that it can be defined as numbers. From numbers also there are two forms of numbers. One is what we know as continuous numbers, that means they vary continuously, and second what we know as discrete numbers. So discrete numbers are countable numbers and continuous data, so which represents data measurement. So the continuous type of numerical data is further divided. Okay, this is not necessary for you to remember, but remember that continuous type of numerical data are also subdivided into intervals and ratio, which is known to be used for measuring items. Okay, so right now we are focusing upon two different numeric data. One is known as continuous, the other is known as discrete. Okay, let's go deeper into it and understand what are continuous type of data. So continuous type of numerical data is one which represents measurements. Okay, so they represent measurements. Their values are described as intervals on a real number line. For example, speed of a truck. Okay, so right now we're driving. Suppose the truck is running from Delhi to Mumbai, and it is running at some speed. Okay, so these numbers can have infinite number of value between say running at 80 kilometers per hour to 90 kilometers per hour. Okay, now imagine that you're running a vehicle at 80 kilometers per hour. You can run it at 80.5 kilometers per hour. You can run it at 82.5 kilometers per hour. So basically, between two different intervals, that is 80 to 90, you can have an infinite number of values, and those are known as continuous numeric variable. So continuous variable can be numeric, or the variable can also be date and time. Okay, because you understand that your date and time keeps on moving and it can have infinite number of values. For example, we start with day. From day we come to hour. From hour we come to minute. From minute we come to seconds. From seconds we come to milliseconds. Milliseconds to micro, and micro to nano. So it can have infinite number of value between 1 second and 2 seconds, or 1 minute and 2 minutes. Similarly, it can have infinite number of value when you talk about driving a vehicle at your speed, that is 80 kilometers per hour, 82 kilometers per hour, 82.5 kilometers per hour. Okay, so these are known as continuous variable. The other example of such continuous variable would be when you measure your height, when you measure your weight, when you measure the temperature around you. These are some simple examples of continuous variable. Now with continuous variable, we can do mean, we can do median, we can do standard deviations, we can do variance, we can do most of the arithmetic or most of the statistical descriptive analytics on it. Now this is continuous variable. Let's go on to the second part, which is known as discrete variable. So discrete quantitative data are count of presence of characteristic, result, item, or an activity. Okay, repeat. All of you, I request all of you to look at all your screens. So discrete quantitative data are count of presence of characteristic, result, item, or activity. These measures cannot be meaningfully divided into smaller increments, right? For example, in a household, I think you can have one car, you can have two cars, you can have three cars. But can you all have 1.2 cars, or can you have 1.3 car or 2.2 cars? Is it possible to have 1.2 car or 1.3 car? No. The answer is clear no. Either you can have one, you can have two, you can have two, you can have four. Or if you're Jeff Bezos, then you can have more than 200, 300 cars. But you cannot have 200.5, 200.2, 200.8 cars. So there are a finite number of possible values that you can record for an observation, and these are known as discrete numeric data. Okay, so let us do quick revision. We started with variables, wherein we have numeric variable, we have categorical variable. In numeric, we looked at continuous variable, we looked at discrete variables. Okay, so I am taking a quick 20-second pause. I want all of you to think. If you have any query, the forum is open here. Raise your query on chat box, or you can even raise your queries by unmuting and asking questions on continuous numeric variable and discrete numeric variable. Remember that a quiz is coming up for you in few slides, so please pay attention and think and raise queries.
Any questions, students?
Okay, so now we understand that okay, we have looked at numeric, but the numeric is not sufficient because there are other types of variable as well wherein we can define real life scenarios, and those are known as categorical variable. Okay, so let's start with categorical variable where we understand that categorical data is a collection of information. Remember, categorical data is a collection of information that is divided into groups. Okay, that is if an organization or agency is trying to get a biodata of its employees, the resulting data is referred to as categorical. Okay, now how is this categorical? Let's take an example. This data is known as categorical because it may be grouped according to the variables present in the biodata, such as what is the gender, what is the education level, what is the score that you secured in your education, what is the number of years of experience you have, or what is the state of your residence, etc. So these are known as categorical variables. Categorical data can take on numerical values. Remember this carefully. Categorical data can also have numerical value like 1 or 2 or 3, but those numbers don't have any mathematical meaning, right? So you can represent yes as 1, no as 2, and maybe as 0, but then you cannot sum 1 plus 2 plus 0. We cannot sum it. We are only representing a natural language with a number, but we cannot make arithmetic operations on those categorical data. Okay, so we cannot subtract it, we cannot add it, we cannot divide it, we cannot do anything on those numbers. They are simply a representation of categorical data. So categorical variable has values that you can put into a countable number of distinct groups based on the characteristics. For a categorical variable, you can assign categories, but the categories have no natural order. Okay, there is no natural order. If there is a natural order, the categorical variable is known as ordinal variable. Okay, remember this. If there is an order or a natural order, it is known as ordinal variable, and category variable are also called as quantitative variable or attributes variable. Okay, so going forward we will understand ordinal variable and nominal variable. But right now, if all of you can focus on the slides where I have given some examples of categorical variable. Okay, this categorical variable could be what is the type of payment that is made. For example, if you want to buy something, then on your payment gateway you can get either it could be internet banking, it could be through UPI, it could be through any credit or debit card. But then there are finite number of different options. So those are known as categorical variables. For example, the countries you travel or the continents you travel. Now you can travel Africa, you can travel Russia, you can travel different countries, cities, but those are finite, right? So these are known as categorical variable. But does they have any natural order? It's like when you define America, when you define Europe, when you define Russia, or you define Africa, or you define Asia, is there a natural order in it? There is no natural order. So where there is no natural order, what are those type of variables we are going to look in the next slide. But now either you secure distinction, you secured first class, you secured second class, or you did not pass. Does this have a natural order? Yes. Either it from a descending order perspective, it could be the first one would be distinction and the last one would be did not pass, and from an ascending order it could be did not pass to distinction. But then yes, they have natural order. Okay, so something that is natural order, something that has no natural order. So those are known as ordinal and nominal, and now we will look at all those different types of variable. But remember this very carefully because going forward we are going to use all of this. So ordinal variable have at least 3 categories, and the categories have a natural order. Okay, this is very significant that the ordinal variable of natural orders, these categories are ranked, but the differences between rank may not be equal. For example, first, second, and third in the race are ordinal data. When you were running on a 100-meter race, either you stood first, you stood second, or you stood third. But the difference between first and second, second and third may not be same. So it means I was running 100-meter race. I finished that race in 10 seconds. The second person who achieved the rank, uh, say, completed the race in almost 8 seconds, and the third one completed in 5 seconds. So 10 to 8, there is a gap of 2. Between 8 to 5, there is a gap of 3. So, but we can arrange them as first, second, and third. But the differences between first, second, and third may not be equal. They can be different. So the difference in time between first and second place might not be the same as the difference in time between second and third place. So if this is a classical example of ordinal variables. Now let's very quickly talk about nominal variables. So nominal variables have at least three categories, and there is no natural order to these categories. Okay, let's take example. All of you might be watching Netflix, or you might be watching Amazon or any other portal. So there are different subject of movies like science fiction, like drama, or comedy. These are different categories. You have some movies which are called as science fiction, you have some movies which are known as drama, and you have some movies which are known as comedy. But then, is there any natural order? Does anybody say that comedy comes first, science fiction comes second, and drama second, drama third? No. Can anybody call out and say that the drama is first, the second is science fiction, and comedy is third? There is no natural order to this example, and where there is no natural order, but there are limited categories, that type of variable are known as nominal variable, right? So, friends, what we looked right now, what we studied on the screen is known as different types of variables, wherein we started understanding that okay, we have numeric variable, we have categorical variable. Numeric variable can be represented by numbers, and categorical variables can be represented either by natural language or it can be represented by numbers, but the numbers have no meaning there. Okay. Numeric variables can be continuous where we have finite number of variables between two distinct numbers, and it can be discrete where the number of differences are finite, and continuous is where the number of differences are infinite. From here, let's go on to categorical variables. So in categorical variables, we have ordinal, that is natural order, and nominal, that is no natural order. Okay, so let's take a quick break, 20-30 seconds break here, and then I and there is a quiz right now. I want all of you to take 20 or 30 seconds of time, write down on your notepads, because I want all of you to share what is engine start or stop on the chat box. Okay, so please be ready with this, and we request all of you to share what are this type of variable. Take 20 seconds of time, and then you can write it on the chat box. Okay, so let's see right now. Let's see if somebody is ready to volunteer, somebody is ready to share. Please feel open. Even I don't know these types of variables. I want all of you to help me understand what is engine start or what is engine stop. Okay, very simple question. Our first question is engine is run, engine is start, or engine is stop. What are these type of variable? Okay, let's go back to the slide. Let me help you. We understood that either engine could be start or engine could be stop. When we say engine is start or engine is stop, there are only two values that can take place here. Okay, and these two values are represented by natural language, start or stop. Okay, so now Can anybody tell me if the value is start or stop? What is this type of variable? Is it numeric or is it category? Most simple question. Start or stop is numeric or is it category? Very quickly, I suggest every one of you to write it down on the chat box. Start or stop as numeric or category. Very good. We are receiving informations. Yes, Ashmita, Hemlata, very good, very good. So these are known as categorical variable because they are not represented by number. Now let's play a twist here. Okay, the same category which is known as start or stop. I am simply representing this category start as 1 and stop as 2. Okay, now this is a trick question. I talked about this that we can represent a categorical variable with numbers, but the numbers have no meaning. Okay, so right now I'm saying that start is 1 and stop is 2. I am repeating, start is 1 and stop is 2. So right now my values are 1 and 2. Is it numeric variable or it is categorical variable? Okay, quickly answer. Is it numeric or categoric? It is 1 or 2. Numeric or category? Come on, very quickly. Some of you are answering right, some of you are answering wrong. Okay, we are receiving categoric and numeric both. It cannot be both, it can only be one. So when you represent a categorical variable with numbers such as start becomes 1 and stop becomes 2, it is still a categorical variable because can you add 1 plus 2 or can you add start plus stop? We cannot add start plus stop, and that's why if we represent a categorical variable with numbers such as 1 or 2, it still remain categorical variable. Okay, so now my final question to all of you on this is engine start or engine stop. What is this variable? 10 seconds. I request everybody to answer on the chat box. Perfect. Very good. Very good. Very good. Yes. So all of you are now right that engine start or engine stop is a categorical variable. Perfect. Now let's go to the second question, which is speed of vehicle. Okay. Now assume that you are driving your car and I am measuring the speed of your vehicle. Your speed is say 30 kilometers per hour. Your speed is 40 kilometers per hour. Your speed is 40.5 kilometers per hour, or it is 50 kilometers per hour. Now 10 seconds. Everyone write down what is the variable type, which is speed of vehicle on the chat box. Speed of vehicle. Very good. It is numeric. Absolutely, absolutely right. Everybody, all of you think that it is numeric, or any one of you believe that no, it's not numeric, it is categorical. Okay. Okay. So we are receiving answers. It is numeric. It is numeric. Absolutely right. A round of applause to all of you. That yes, it is numeric. From here, let's take third example. That is now a difficult question, and I'm not going to give you a hint this time, but I want every one of you to take 20 seconds and help me understand that if I have life of vehicle, the life of vehicle can be less than 5 years, it can be between 5 to 10 years, and it can be more than 10 years. Okay, what is this variable known as? Very quickly, every one of you, less than 5 years, between 5 to 10 years, and more than 10 years. Come on, is it category? Is it numeric? Don't only look at the value 5 or 10 here. Understand that what am I trying to see? Is it less than 5 years? Yes. Is it between 5 to 10? Yes or no? Is it between more than 10 years? Yes or no? Come on. The answer is yes or no. Yes or no. What type it is? Yes, we are getting good answers. Categoric. Very good. Very good. So it is a categorical variable. Now the trick question. In categorical variable, Is it nominal or is it ordinal? Okay, this is important for us to understand. And let me repeat that ordinal variables have natural order. Okay, it means 5 to 10, it means less than 5, 5 to 10, or more than 5. Does it have a natural order or it does not have a natural order? And ordinal variables are the variables that have natural order, and nominal variables are the variables that do not have a natural order. Okay, so now this life of vehicle is nominal or it is ordinal. Come on, very quickly answer everyone. Is it nominal or is it ordinal? Okay, waiting for your answers. Ordinal, very good, very good, very good. Yes, it is ordinal. And now let me ask you a quick question. Yes, very good, very good. Everyone is responding. Everyone is responding well, and the answer is right. That this type of variable are known as ordinal variable. Now the trick question is why? Why ordinal? Why ordinal? Come on, quick. Why this type of variable are known as ordinal variable? Why are these known as ordinal variables? Come on. It has specific order. Good, because it has a natural order. Wonderful answers. Wonderful answers. Yes, because different is difference. Difference is different. Very good. This is also right. And all these have natural order, and that's why we call ordinal variable as ordinal, and nominal variable do not have any natural order. Okay. So now I am repeating my point that life of variable either could be less than 5 years, between 5 and 10, greater than 10. It has a natural order, and that's why it is known as ordinal variable. Very good to every one of you. Now let's take another example, that is fuel economy. Okay, fuel economy means either you are getting, what is the average of your vehicle? You are getting 10 kilometers, 20 kilometers, 30.5 kilometers, 40.5 kilometers, whatever you are getting as the fuel economy of your car or your moped. So fuel economy is a numeric variable or it is a categorical variable. Numeric. Very good. Very good. Very good, Vaishnavi. Yes, it is numeric variable. Absolutely right. Absolutely right. Very good. It is numeric variable. It is numeric. Good answers from everyone. Now in numeric, is it continuous or is it discrete? Okay. So either you can get your fuel economy as 10.5 kilometers per liter, you can get 11 kilometers per liter, you can get 20.5, you can get 20.25 kilometers per liter. So where you have infinite number of values, then those are called continuous or discrete. So the question is that the economy of your vehicle is continuous or is it discrete? Very good, very good. So we started receiving answers. It is continuous. Every one of you is right. Good. Every one of you is you deserves a round of applause. Okay. Absolutely right. So I am sure now all of you have understood what are different types of variables and what is the importance of variable, why it is necessary to understand what are different scenarios around us wherein we want to develop, wherein we want to identify a machine learning model, and then what are the different types of variables. Okay, good, well done. Let's proceed with this, and now we are going to understand how to describe the numbers. You have got the data with you, but then the data which is available with you, we can't simply look at the data because it can be huge. It